Right, yeah, welcome back again to another segment of this course. We are looking at data processing and dealing with missing data. Like I said last time in the theoretical section, that missing data is very important because it affects the data. It has a major effect on the analysis of the data. Major effect. So because of that, you need to deal with it. If not, your data lacks a lot, it lacks integrity, and it will compromise the delivery. So we need to find way of handling the missing data in order to make our data clean. This cleaning data, we call it data wrangling. Alright, so we want to clean the data. Now, data come with different kind of noise, and you can see that the missing data is one of them. If you don't understand what I'm saying, go back to the previous class, which is under the introduction. You can understand better what I'm talking about. I'm detailed that here, so you just want to apply that which you have learned there practically here. All right. So the first thing I want us to look at is dealing with missing data here. All right. So we tell you the first thing that first finding missing data. You need to find first. You can have a large data set. You may not even know that there's missing data there. You may not know. You may not know. So you need to find. So let's create a data frame first to start. Okay, let's start by creating a data frame of core data. That's our data. I have variable A, B, C. Right. So let's run this line of code. So this line is called run. So we can now see what is inside. We have data. So our data have a NA. NA means missing data. Okay. Column A has 1. Column B has 2. Column C has 2. Right. So that is our observations. We have 1, 2, 3, 4, 5. So we have 5 observations. All right. So we learned some method last time at how we can handle missing data. Okay. So you can see that here there are other ways you can do this. Okay. To check, because if you have a very large data set, you may not be able to see the missing data very easily like that. You may need to scroll to see. But the fastest way to check is to use summary method. Summary. Okay. If I say summary rather now, so we see data. All right. That we able to understand if there's missing data. Okay, look at it now. I try to summarize my data. So under column A, I have NA. I mean NA. N is 1. Under column B, N is 2. You can see here. Under column C, I have N is 2 also. So when you first do this, no matter how large your data is, so it will break it down to you in this form. Okay, if you have 20 columns, 30 columns, you'll be able to see in this form. All right. You can scroll down and now know how many have the missing data from your columns. How many missing data do you have in each columns? So you can give us, if you have 20, to show you 20, you show 30, you 40, you will see the missing data in each column. So that is what I'm talking about by using summary function. All right. So now that we have seen that we have missing data, okay, we need to apply the next method. Okay. So the first thing is to checking if there is any missing data. Another method is to check to say if NA, look at it now. If NA data, and it's another method to check. If you run this line of code now, it will check for us either true or false. Okay, this will give you false and false. You can see is it true. Whenever you see true there, it means there is what missing data. Under if you use is if NA is NA data, it will give you whenever you see true, it means your data has missing data. All right, so you can also find total missing value in data set. So by saying sum is NA, so we want to find the sum of total missing data now by running this line of code. Okay, we run this line. We say 5. Okay, to go total number 5. You can see we have 1 here, we have 2 here, we have 2 here. That is 5. So you can still use one to check even though this one is not telling us which columns, but this one is giving us the column, all right. But here, it's just telling us the total number, right? So he said he was telling us in under A we have true, 1, true. Under B we have 2, 1, 2. Under C we have 1, 2. So it's giving us where you have missing data, which is true, 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 true. So you'll be able to know which place you have true throughout. Then you want to know the total, you can just use its total, the sum can give you the number. So that is that. So you can also find missing data column wise. This one is row wise, column wise. So if you just say column sum, you can do like this. You may want to do this column by column. That's what it means. If you can supply column A here, A instead of a entire data set here, just A. If I run this line of code now, so give me column 1. So you can see in the other you have 1, 2, 2. Okay, 1, 2, 2. So that is just the concept. Now you can visualizing of missing data values of the data set. Okay, you can visualize. So you have to install a package called FishChat. This package called FishChat. I have to install this package first. So I've already installed. Okay, I don't need to run again. So that you saw install the library FishChat. Then load the library, load it. So when you load it, you can now say this miss data. It will plot for you diagrammatically which area you have missing data and how many are they. If I run this line of code now, okay, I can see the chart. You can see here in my chart here. Okay, let me zoom. Okay, so you can see I'm having this my observations. Okay, this is my missing data. Okay, where do you show you black here? It's missing. This one is not missing present. So we have in this place, this A, I have 20% of missing data, 20%. In B, I have 40%. In C, I have 40% also, which means 1, 2, 2. All right. So totally, in total, I have 33% of missing data, 33% in total that are missing. All right. So, and 66.7% non missing. So it means that my missing data covers this range of percentage. I'll be able to know from this chart, from this diagram here. So that is how to know by visualizing your missing data on the screen. So now, how do you handle missing data? Now, how do you handle? The first thing is by removing values using the delete method. I want to omit every rows containing even one NA. Any row that is containing missing data, you want to remove the row wise. So it means that if I say remove, it will remove this this row, this row, this row, and this row, and this row will be removed. Don't forget this row, this row, this row, and this row. Every row that has NA will be removed. That is first method. Okay, so if you run this line, if I run this line now, this line, I have a new data called data, and that data I have now, it will not include any NA. So I told you before that this method is dangerous because you not have if you don't have enough observations or not enough sample, don't try this method because it will lower your sample size. At the same time, you'll not be able to do a proper analysis. So you need to have a sufficient sample size for you to do this. All right. So if I run this line of code now, we have a new data. I have a new one now called you can see here. I have now. So if I check data now, check my data. What do I have there? You can see I have only 222. Why? Because I have removed this one. I've removed this. I have removed this. I have removed this. I have removed this. So what is left is this. Only one row. Just imagine this is a data set. What do you have left? Nothing is left to work with. Okay. So that is that. That's why you have to be careful about using this method. Okay. Now you can delete rows with missing value in specific variable, which we just did now. Maybe you want to delete it in specific variable now. You don't want to delete just every row, but specific variables. So let's bring in a data set called empty cars. Okay, empty cars is a data set. Okay, data empty cars. It's inbuilt. It's inbuilt. It is inbuilt. Okay, it comes with R.
So the way you access it is by using data, all right, or empty cars. So you can even attach it first. You can attach it. Let's attach it so that it will be easy for us to use. Attach empty cars. Okay. All right. So it's attached now. All right. Now let's describe what is there. What is, let us see. Let us look at what is the empty cars by running glimpse. Let's glimpse it. Um, let's glimpse it. Let's glimpse empty car. What is there? Empty. See glimpse now. Glimpse. Okay. Don't worry. Let me just uh let us see. Let us first see the dimension of the empty cars first. Let's see dimension for empty cars. How many rows and columns first? Okay, 32. Oh, 32 columns and 11 rows. Okay. Okay, so so let's see what is inside first. Empty cars. Let's the first six on. Okay, we have this is MPG, cylinder, displacement, horsepower, and the rest. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So here you want to check, is any missing data here? Though you saw only 6. Okay, let's go further. Let's summarize. Let's find a summary of this empty car and see if we have missing data there. If you to see empty cars, why I attach empty car is because I want to use the variables or the columns inside without the dollar sign. All right. Let me quickly explain that before I go further. Normally, if I want to access any variable inside empty cars, normally, this guy is my data set. I have to use empty cars dollar as you can see here, dollar this dollar each of the variable inside. You can see we have this variable. I want to access this variable now. Each of them have to use dollar sign, which I have explained before. Under variable, you have to use dollar sign to access each of the variable. Okay, but I don't want to use dollar sign. I just want to pass my variable inside directly. Okay, I can attach. When I'm done, I will detach. Okay, so I've attached empty cars so that then I can now use my variable directly here without any problem. I don't need to include empty cars dollar anymore. Just call the variable straight. I mean the column straight. That's all. Okay, so take note of that. So that is very useful. So now we have summarized now. Okay, let's look at this empty cars now. For the first one here, no missing value. Second one, no missing value. Third one, no. Fourth one, no. Fifth one, this one, let me see. Since we have no missing values here, do you have anyone? No NAs. No NAs here. Okay, I'm not seeing any NAs here. Okay, let's look for data set that have missing value. Let's use this guy we are using before, this data now. Let's pass data in this particular one data. Let's use it now. We have A and B. Okay. Let's see the final. Let's see the data. Let me just clean screen. Let me see the data first. Data. This is what we have now. So let's now go back and run data fresh so that we can have a let's run data fresh. I want to use another data set now, but I don't want to jump into that now. Okay, I want to use that later. So now we have our normal data now back again. Okay, all right, we have data back. So let's say we want to by column A, B, C. Can say okay, we take our complete cases. We want to use this. Let's say we want to remove from A and from B. Okay, only let's say from B and C only. Okay, we want to leave A because only just one. So let's say from B and C. So just say we have a data dollar A, data dollar B rather, data dollar B and dollar C. Data I didn't attach that. Okay, so dollar B, then data dollar C. All right. So I have two that I'm dealing with now. So this is I'm doing this one now row wise. Okay, so if I run this line of code now, it has claimed from. So if I now check my new data, okay, hold on. No, sorry, not data. This is my new data now. Clean this one, clean data. All right. So if I run this line, I've assigned this one to. Sorry, I've assigned this one to. Oh, sorry. I see empty class here. Not sorry. It's supposed to be data, not data. Sorry, data. That's the error. So let's run again. All right. So let's now look for the data. Let's now look for clean now. This clean now. We run this one again. Now we have removed. You can see we remove this line. You see, we are only having left NA. Other ones we remove. That's remove. Okay, row wise. We have clear off row wise. Those ones that have missing data. So we have this one left. So you can see that. So now we can replace those area of missing data with values. And maybe A. Now we want to replace A with something else, with maybe with 2 or 3. You can do that. Okay. Okay, that's called inputting with specific value. Inputting missing data with a specific value, e.g. 0, 999, 2, 10, whatever. So we can now let's say our data, let's assign our clean data to A. You can say clean data is a value. So we can just assign 0 to it. Let's say 4. You can put anything based on what you want to put. Okay, so but we're just saying, okay, what can we assign to these columns or column? All right. Let's do it for all of them once and for all. So let's go back and run our missing data again. Or let's run this guy again so that we can know that we have a lot of missing data. Let's run again. So let's check our data again. Okay, we have this again. So let's now apply that method to this guy. Okay, let's apply that method. So we want to assign our dim data to this guy now. Okay, we call it clean data. So clean data is now, we say NA. We want to assign 4. Okay, let's say first assign 3. Let's say 3 to every place we have missing data. Then we now print the current one now. So let's run this code. You can see now, so everywhere we have NA has been replaced with 3. I say 3, 3, 3, 3, 3. So that is, so you can, if you have let's say that you want to replace some columns, you can do it row, can do it column wise. Okay, column wise. So you may not need to do the same thing. Maybe for this particular one, I want to put 3. This one I want to put 4. So I want to put 2. Can do it column wise. Okay. So just call the column name. Say dollar data dollar the column name. Then just apply it to that column. So don't apply it to everything. That means you want to do column wise. You do one by one, one by one by one. All right. So that is that. So you can use a mean or median imputation. So this is very common, and it comes in handy when you have want to do a proper approach that will retain the shape of your data set. Okay. If you check very well our data set, let's introduce a new data set now called air quality. It's inbuilt as well. Okay, it's inbuilt. This data set air quality, it has missing values, so you can use it to test. Right? Let's check. Let's check. Um, let's check what is inside. Let me see if I can glimpse. Air quality. Yeah. But what is going on? Was that my glimpse is not correct or what? Never mind. So let's see the first six data. First six head air quality. So we have ozone, we have solar hour, we have wind, we have temperature, we have month, we have day. So let's now summarize it. Let's summarize. We can summarize like this, okay? We don't want to summarize everything. Don't mind this line of code, okay? It's a test. We're using a pipe to summarize just some line, not all. Ozone, wind, and temperature. So you can see, because those are the ones that have missing data, okay? But you can summarize everything. Let's summarize everything first. Summary, air quality. Okay, so you can check here. This one have 37. You can see here, 37 missing data. They one have 7. Okay, for solar have missing. They don't have 7. Which other one? I think that is only 2 that have missing data. Only 2. Is that correct? Yes, only 2. This and this. 37 and 7. All right. So you can apply other method by saying it's missing data. You can say it, but at least you can check from here directly. You already know which column that having and how many they are having. So we have 2 columns having missing data now. So okay, so you can now go ahead and apply imputation now. All right, calculate the mean of non-missing data value. So here, what I want to do, want to assign mean to it. Want to impute use imputation method by using mean imputation. So the first line so you can do it in 2 ways. The first way is to use a piping, right? And the second way, but you can use directly by calculating the mean. So mean is ozone na.r. So we want to do it one by one. So we don't want to do everything together, even though we can do that actually. We can do it together anyway. But let's do it column wise. Mean ozone na equal to true. You input missing value for na ozone. So if you say input mean value, say if is ozone na ozone, then mean value ozone. So pass the mean value of that column. Okay, this one, this column. What to do? So if you the reason why we are using mean or median is that that will help us to remain the shape of data. You can see that median is here. Our median 31.50. Our mean is a 42.13. This particular must be able to retain the shape of the data. You shouldn't disrupt the data, because after you have finished imputation, sometimes if you don't follow the proper approach, you say that your data has already changed. You shouldn't change data, because it won't be good for your analysis. So that's why we prefer automatic imputation by using mean or median. Okay, so that you have to retain the shape of the data. So if you apply this method now to this ozone, for example, if you run the ozone again, summarize again, you see that we still have this thing there. All right, let's see what I'm talking about. We can also use the same method here. You can say air quality. Okay, you can assign here mutate ozone if S is Na.
then mean also NA. So let's try this. It's the same thing, okay? Same thing here we are trying to do here. So you can apply the method here. Mutate to some. All right. Let me check my tidyverse. I don't know if tidyverse is still running. Oh, I don't have tidyverse. Sorry. Let me just library tidyverse. Okay. All right. All right. So now we can go ahead now. No wonder many times are not working. I wanted to glimpse. Okay, you can see now glimpse is working now. Oh, that's why it's not working, because I didn't load the library all this while. Oh, sorry for that. So, all right, let's now go back now and do what I wanted to do. All right, so we've summarized this. So let's apply the imputation now again by running this line of code again. So we have to see now. So you can see now it's working now. So we have a new air quality now. All right. So that is different. Advantage of this particular piping is that it will retain the same data. You can see now. You can see what that data set is still retained, but has been modified. So you don't need to be disturbing yourself in that data set. When they modify ozone, but the data set is intact, but ozone has been modified. So if I now check my data set now, summarize again as a summary now, let's try and see air quality again. Okay, let's look at ozone. You can see ozone has changed, right? Has changed. We use mean for this purpose. You can also use median. Median seems to be better. So let's change to median. Let's say median. We have that in here. Okay, median now. All right. Let me go back and clear that from ozone. Let's rerun ozone again. Data quality, because we didn't separate our data set, assign it to another data set. Okay. So you see how for instance, this data intact now. If I run ozone again, this data is intact. It's there. So let's apply median. Okay, median for this. So this median method. Don't forget our this median 42.3, mean 42.3. All right, for zone. Okay, maximum and minimum remain the same. So when we first run the I've cleared it off. Let's run the original one first and see what is inside. Summarize original. Summarize. Let's summarize the original data and see. Air quality. Excuse me. Let's see now. Oh, I'm running. Oh, sorry, I'm running. Air quality. Okay, let's see. Yeah, let me check first. Okay, it's that is there. It's back. So let's now let's summarize it now and see. Yeah. Okay, so we see how for 37 intact now. So let's now go and apply what I want to apply, the median right now. So this median. So I can now say let's change this to variable to something else, so that we can retain our data quality. So to compare, so let's call it a 2. Okay, let's call it 2, so that we have a new data set called 2. All right, so let's run this line of code. We have run. So let's now see, fine, we are going to compare. Now we have 2. So let's say summary air quality 2. All right, so we have NA 7, 37 rather. Okay, we are doing for solar now. Sorry, for solar.
let me change to zone. I want to check. We have done for zone, so we are doing for solar. So we didn't do for zone now because we have a new data set now. So let me apply the same thing to zone now. Zone. So wherever there is a, I just add a zone there. All right, so let's do for zone now. We have done for this, ready for zone. All right, so let's check again our air quality now. Summary. Air quality 2. So we have done for ozone now. This is ozone now. So we can see. So this is our median 31, 39. So for original one, for original data set, let's say summary. Air quality. For original one, so we are having 31.50 as median and mean 42.13. But when we after we have done that, before we do that, so we have our minimum was 1 and maximum is 168. Here minimum is still 1, maximum 168. Okay, for the that's original one now. It's original one. Okay, the original one we have a first quarter 18, third quarter 63. Okay, first quarter has changed actually. But we also have original we have 31, median and mean. So median and mean. So median and mean, that is 31 is median, is still intact. So mean change a little bit to 31.50. Here you have 40 mean of 42. Okay, so our shape of data is still not too bad. So we can see continue. So you can apply the rest for all other ones, other columns you want to apply for, so you can have a clean data. But a lot of you don't want to do that. You don't want to do that. This method is somehow dangerous. We have a better method called a misranger. So this one using random forest, and this one is advanced method. Okay, just apply random forest techniques to do the work. By it's as if you are doing machine learning. So we have to run this line of code first. This library called misranger. Okay, you have to attach first. Don't mind the warning. Okay, so we have to check in the air quality data which one of them you have check the data set, entire data set. Okay, then pass use your own. You go to use its own method, right? Okay, if you check, for example, now if you check misranger, for example, let's see what I'm talking about. Misranger. Okay, so misranger. Look at the description here. Misranger here. Fast imputation of missing value by chain random forest. Okay, so this is using chained random forest. All right. This technique is a formula here. All right. You can see that's other parameters and the samples on how to apply. Okay, so you can see it here. So now air quality is data set. Okay, and formula here is the method we are using. So don't change this one. Okay, we're applying for all of them. Don't change this. So just leave dot this dot comma. Then you can set seed if you want to set seed. It's not important. Okay, this is for a possibility to reproduce the data set, so you can have the same, because you got to supply different values so that if anybody want to do the same and use the same seed to have the same answer, that what I mean, have the same result. Okay, because the value can change, okay, on different system. All right, so now if I run this line of code now, it will give me a new data set called div. All right, or my misranger. So if I run this line of code, so it's working now. Iteration is working. It has finished. All right, what about to say missing value imputation by random forest variable to impute ozone and solar. It showed me the two variables. All right. So these are two variables that I work on, right? So what did they use? Variable to use to input, use ozone, layer, wind. So it's checked through all the variables to see their data, how they look like. All right, how they look like. So for to input, so iteration 1, 2, 3, and 4. Before you finally done, you have done the imputation now. So I can look at the plot here. Okay, let me see if I can get the plot. Sometimes it shows error for the plot. I don't know why. Plot NA Peroto. Okay, let me see. Let me see. Okay. So it's not available. So never mind. So let's try and see using this guy. All right, let's use this guy. Okay, let's zoom out. So press 100%. No missing data anymore. It has done it. Please. Okay, no missing data here at all. 100% present. So that's what I want to use. I want to show also, but you can use the alternative. So you can see that it's clear. All right. So we now have a. Let's see our div. What is this? Our div. Okay, our div variable. That's our new data set now. That was our new data set now to change. All right. You can see ozone, solar, wind, temperature. That's true. We have new data set now. All right. So that is what you have done. So that has changed. Don't forget some are zero value. Okay, some are zero value. But I don't. So sometimes you may not like what it does. Okay. But let me see. This is what it imputes. Let's see, edge. Okay. So we have 41.000, 36.00. So the data does not affect the data much. You can see. Okay. Let me see. Let me show you what I'm talking about. We have a new div. Okay, our div is our new data set now. So let me compare by summarizing now. You understand what I'm talking about? Let me summarize. Summary. Let me do summary. Let's first check the old one. Old one is air quality, right? Right. So we have 37 NA, 7 NA, median 31.50, mean 34.2.70. Let's check summary for new one now. Summary for div. All right. So no more missing value here, but we have 32 median, mean 41.71, and this one we have 31 median, mean 42. So look at the median 32, 31.5, 42.13. Look at it, it's 32.4, 31.2, 42, 41. No different, no more changes in the shape of data. You see, it's still intact. That is what I'm talking about. Look at the median here, 197.0, 184.0, 184.4. Look at this one here. Okay. Yeah, that's 207,185. So the distance is not too far. So you can still maintain some shape of the data. So you can see that this method is better than other methods. Okay. So we have a new data set now called div. So you can save this div now and use it separately. So you can just say, let's save this. Let's say write.css. Okay, write.csv. Our new data is called div. Data set is called div. Okay. So let's say we call it file name. File equals to which name do you want to give it to? Let's give it new. Let's call it new air quality. Air quality dot csv. So You want to save into so that it's saved. So we have saved it now. So we can now run it afresh. So become a new data set now. You can import it now and use it normally, like another normal data set. So that's how you, when you finish your data, normal data, no matter how big it is, you can now bring it out and just export. So this particular last line is very powerful. This particular one, this particular range, miss ranger, is very powerful. It reduces a lot of effort and make your data a new data set, but it doesn't lose the data shape of the data. Because sometimes when you do that in imputation times, the data will lose data shape of the data. But for imputation, it doesn't do that. It will retain the shape of the data. And that is how we stop today for this particular episode. So we continue from there next time. We look at something else. So take note that there are many methods to apply when it comes to missing data. And what is important is for you to make sure that your data is clean and it doesn't have any missing data. And then now you can continue to analysis. I will see you later in the next section. Thank you for joining us today. I'll see you later. Thank you.